Our next problem is about a satellite traveling in a circular orbit 1,600 kilometers above the Earth, and it takes 2 hours to make an orbit. It says find the linear velocity of the satellite. Linear velocity is our distance over time. Distance would be our arc length, so S over T. Now, looking at the information that we have, let's come back to our picture. They're saying that the radius of the Earth is 6,400, but our satellite is up here. We are going to have to add on our 1,600, how far the satellite is above the Earth, to get our total radius, which will end up being 8,000 kilometers. So coming back to our problem, we have, in place of our S, let's change, we know S is R times theta over T. And we're looking for our linear velocity. We're going to use our R. The R that we found was 8,000 kilometers. That's the radius of the Earth, plus how high the satellite is above the Earth. And it says it's going to make an orbit in 2 hours. One orbit is one full circle, which is 2 pi. And then our 2 pi, it takes 2 hours to complete that orbit. From here, our 2's end up canceling, and our linear velocity will be 8,000 pi kilometers per hour. And then the next part is saying find the distance traveled in 4.5 hours. Well, if we come back to the formula we started with, we now have our linear velocity, and we have our time, and we're looking for our S, our distance traveled. So if we wanted to cross multiply this formula, we would have S equals linear velocity times time. So finding our S, our linear velocity, is what we just found, is at 8,000 pi kilometers per hour. And then our time is 4.5 hours. Our hours will cancel, and we end up with our arc length. And if you multiply that out, it's 36,000 pi. And our units are just kilometers, and that is our distance.